So we'll start the session 12.
Okay, sir.
So let's introduce Engineer Himanshu Kumar Das. Received his BTech in Electrical Engineering from University College of Engineering, Burla, BPUT in 2003. Served as a ad hoc faculty in UC Burla for one session. Thereafter joined Hindalco Industries Limited in captive power plant at Hirakud at 2003. Worked in various capacities in CPP and smelter as station in charge in captive power plant operations CPP 467.5 megawatt and smelter electrical and instrumentations rectifier stations. Total industrial experience span around 21 years. Presently working at Aditya Aluminium Lapanga Hindalco Industry Limited as head of E&I carbon plant smelter. So
Thank you, sir.
Yeah, you can share your slide.
Yeah. Thank you, Professor Sarath, sir. Thank you for this opportunity for sharing this presentation on rooftop solar to our students. Now I'm sharing my screen.
Yes, it is visible.
Yeah. So to start with the topic, this is very interesting topic because this rooftop solar has gained a lot of popularity during past few years. This is because there is a lot of push by the government, by the state utilities, and literally it is giving a cost benefit to the end consumer. So let's start with this exciting topic of rooftop solar installation. And this is the contents. So in this topic, in this presentation, we'll be going through the definition of rooftop solar and advantages. What are the working principles, solar rooftop installation types, and what are the major key components for rooftop solar installation? What are the factors that affect solar generation? What are electrical protections in a rooftop solar system? What are the operation and maintenance aspects of RTS system, rooftop solar? And what is the RTS potential in India? So from here on, we will be telling it is RTS. Normally the term which is very favorite, it is rooftop solar, we call it RTS. And few insights about RPO obligations, that is renewable purchase power obligations. And after that, we will be going through few of the videos that is available on YouTube. So I request all the participants, it's a two-way session. So definitely wherever you feel that you need further certain clarifications, definitely please come forward and unmute yourself and share if any question is there, or at the end of the session, we can please park your questions. You can share your questions at the end of the session and we'll be happy to answer that. So going ahead with the presentation, first, what is a rooftop solar system? So rooftop solar system, it's a array of solar panels. Normally, as the name says, it can be placed on the roof. So the roof of commercial institution or residential. So this will be a natural way of harnessing energy from natural sunlight. So that's why it's a renewable energy. So that will be going through renewable energy concept in further slides. Very popularly, these solar panels, we call it solar PV. So in the technical literatures, you will find that solar PV is the term which is very which is regularly used. So PV stands for photovoltaic. So solar photovoltaic, that is solar PV panels, it captures the natural sunlight and converts it to electrical energy. So how this happens, we will discuss in further slides. So few things about our physics that we have learned. And it is pollution free and environment friendly because it is free from harmful gases. And it preserves the natural habitat around the installations. Why? because in this we don't have any combustion process, we don't have any gas emission, we don't have any dust emission. So the natural habitat around these installations, these are preserved. And moreover, in the future slides, we'll see that in few of the case studies, like we have not rooftop solar, but a solar power plant in Rajasthan, where we have done wonders in India. So we'll be going through that. Now, again, continuing with the advantages of rooftop solar system, it can produce large amount of solar power during the daytime, and we can use battery backup system, battery storage system. We can store the energy and use in off-peak hours or during night hours. And with this is very cost effective because this helps us in reducing the power bills substantially. This is because we generate a part of our or even fully the amount of electrical energy that we use in our households daily. Then excess solar energy that we produce, suppose we produce the energy with solar cells, but we don't have the demand. Suppose my total demand of my home is 1 kilowatt, but I am producing 2 kilowatt. So what will happen to that rest energy? Yes, we can earn some money. We can earn some incentive in terms of electricity bill. That is, we can send it back to the grid through the utility network, and in turn, the amount of that particular units that we have pushed to grid, that will be offset from our bill. So it is a cash incentive, we can say. And in turn, this helps us in we can say the reducing the worries of the utilities. That is because we produce what we generate. So here what happens, the loading of the utility transformers, like the region where I stay, this is under Wesco. Similarly, it was Wesco and now it is TPWODL. Similarly, Tata Power has taken it is the distribution license in Odisha, and in various regions it has got various names. So what happens, it purchases power from the national grid and it brings it to the users, industrial customers, as well as the domestic customers. Now, for the domestic customers, situation becomes much more challenging, because we know that the growth of buildings, the growth of human assets that consume electrical energy, it is growing day by day. So suppose you think the utility has installed a 1 MVA transformer, and there is a say around 500 households in that zone. Now 5 years ahead, suppose that 500 households, it expands to 2000 households. So what will happen to the 1 MVA transformer and the utility network that the utility company has installed? So this has to be augmented definitely. So that's why Government of India is promoting this solar power, which means indigenous generation of solar power by the users itself. So this automatically reduces the loading on T&D, that is the transmission and distribution network, and especially in peak hours during the daytime. So this helps in reducing the transmission and distribution loss itself to the state utility. And moreover, there is an improvement in the tail end voltages. That is, we know that suppose we are in a locality where we have say a 1 MVA transformer for our locality. Now what will happen if we go on adding load and without adding substantial capacity to the transformer MVA rating? Then what happens, ultimately a point comes when the total bhar, that is the reactive power demand required by these households, it cannot be met with this transformer. That is, the MVA rating of the transformer is not sufficient enough to drive the MVA load. So what happens, there is voltage drop. So if you can imagine of a situation, if majority of the customers or majority of the consumers who have feasibility of rooftop solar installation, if they produce what they consume, then automatically this low voltage issue will not be there. That means the active and reactive power demand by the households can be generated by them, and in turn this will reduce the kilovar, means MVA rating, that is kilowatt and kilovar loading on that. It will reduce the loading of the utility. So these are advantages. Now coming to few more things on these advantages. That is, the peak hours, the load can be better managed by these distribution companies. We normally call them discoms. And it is long-term energy. That is, if we install a solar power plant, then it is typically it has got a lifespan of 25 years. So we'll see that how, no doubt de-rating is applied to it, but we will see in further slides how it happens. So this is long-term energy and this is free energy, we can say. Suppose in 5 years we get payback, then the remaining energy that we get, it is almost at zero cost. Then meeting renewable purchase obligations, that is RPOs. This is something a legal term and it is mandatory for the obligated entities. So what are the entities who are obliged to comply these RPO guidelines of honorable government? That will be going through in further slides. Also, there is financial incentive by Government of India, that is up to 3 kilowatt, there is 40% rebate. So we call it CFA benefit. So we'll see that is called Central Financial Assistance. So in further slides, we'll be going through that. And moreover, the vacant roof space that is utilized, and by that we generate some energy, even we can generate some finance for ourselves, as well as this will help in reducing the roof temperature in most cases. In places where the sunlight is the fall of sunlight, that is in watt per meter square, is very high, where there it is a very helpful solution to keep the homes a bit cooler by installing these solar rooftops. My voice is audible, friends?
Yes, it is audible.
Yeah. So with this advent of solar technology, solar PV cell technology, a new term was introduced that was called prosumer. So as the name says, it's a combined word, that is consumer and producer. So the concept is produce while you consume electricity. So the new term now that is a buzzword in the industry, that is prosumer. So what is the definition as per OERC guidelines? Prosumer means a consumer of electricity in the area of supply of distribution licensee who uses a self-owned or third-party owned solar power system installed at the customer premises to offset a part of the consumer's electricity requirements. So this is a very important definition where you can see the thing that is inbuilt into the definition. It can be self-owned or it can be third-party owned. So big residential societies, if they don't want to invest much for this rooftop solar installation, they can hire it. Means third party are there who can install the solar system on their behalf, and there will be agreement between the residential society and the third party, and there will be an agreement for sale of power to grid between the residential society and the utility of that area. So this is how the system works. This is how the equation works. Now, coming to next slide, few of the basic principles. So if we go into Google, we find that these solar PV cells, these are made of? Basically, these are a PN junction. So PN junction means P-type silicon and N-type silicon junction. So why silicon? So let's go back to our physics class, that what we have taught during +2 first year or second year, or even in CBSE 9th standard also, 9th, 10th also, we normally cover it. So silicon is an atom, the symbol is Si, and its atomic number is 14, and atomic weight is 28.085 Armstrong unit, AU. So silicon has atomic number 14. What does it indicate? It has 14 proton and it has got 14 electrons. And the number of neutrons, that is 28 minus 14, again 14. So the point of importance here is the number of electrons, that is 14. Now, if we can remember the Bohr-Johnson model of atoms, here what it says that these electrons are in various energy levels. So we call it KLMN. There are 4 cells. The innermost cell just after the nucleus, it is called K level, K energy level. then L level, then M level, then N level. And the distribution of electrons 2, 8, 16. So by following Bohr model, what will happen? You can see that the innermost, that is the K level, I am adding the pointer here. Just 1 second. Yeah. So if this is the nucleus where protons and neutrons are there, so this is the innermost level. So this we call K energy level, where 2 electrons can maximum reside, and then L level where 8 electrons can maximum reside, and the remaining will go to L, and L level maximum 16 electrons can reside. So 2 plus 8, 10. So now the remaining is 4 electrons. And the second theory that this Bohr-Johnson model says that the this atom always tries to accept or reject electron to maintain 8 in this outermost cell, that is called the valence cell. So why this silicon has got a special property? Because it has 4 electrons in its M level energy, M energy level, that is the valence cell. So silicon has a valency of 4. Now that means it can either, it is in between. So always an atom tries to have 8 electrons in its valence cells. So it has got, this silicon has, since it has got 4 in its outermost energy level, that is in M level. So it has got an excellent tendency to donate as well as an excellent tendency to accept electron. So when let's go a bit further. So I don't want to confuse you all much, but you can just recall that we had learned the term doping during our study in +2. Doping means it is the process of adding impurity to semiconductors. So why it is done? That is to improve this its electron accepting or electron donating capability to improve. So adding a pentavalent impurity to, like phosphorus to silicon, this leads to covalent bonding of 4 out of 5 valence electrons in each phosphorus atoms. So just you can see that it is adding a pentavalent impurity, there will be 1 extra electron. So this electron is very loosely bonded and with very little energy, that is even at room temperature, the thermal energy of room temperature is able to free that electron. So this we call N-type semiconductor. Similarly, what happens in P-type semiconductor? In P-type semiconductor, I'm just switching up my video so that streaming quality will be better. So in P-type semiconductor, we add trivalent impurities like boron. So since boron has valency of 3, so when it is combined with silicon, it has got tendency of accepting 1 more electron. So P-type has the ability to accept 1 electron and N-type has the ability to donate 1 electron. So this is the basic fundamental behind a p-n junction in solar PV cell. So in next slide. Just 1 second. Yeah. So this solar PV cell or solar photovoltaic cell is nothing but it's a PN junction with a depletion region in between them. Now, I'm again adding pointer. Yeah. So you can see the upper layer, the outermost layer normally which is visible to us, that is N-type layer, and the bottom is the P-type layer, and just below that it is a metallic substrate or base which forms the positive. So there is a nickel plated bracing or aluminum bracing at the top of the cell that you can see normally. These are the negative contact. So what happens when the solar energy of the solar radiation falls on a solar PV cell plate, then the photons, that is the small packets of energy, small quantums of energy that is resident on a solar PV cell, it helps the N-type semiconductors to lose their loosely bonded extra electron. So that's why this upper layer acts as a source of electrons. So definitely this upper terminal, this becomes negative. Now this p-type semiconductor at the bottom, it has got the great affinity to accept one electron. So therefore, when we connect this top layer that is negative and bottom layer that is positive to a load, then there is a flow of current at the circuit completes. Now you can ask here, what is the role of this depletion region? So this depletion region, it acts as a barrier between the n-type and p-type semiconductor, so that direct flow of electrons doesn't take place from this upper layer to the lower layer. Otherwise, there will be a short circuit and there will be a junction failure. So this is the whole fundamental behind a solar PV cell PN junction. So to elaborate it further, basically the incident solar light, which contains certain energy packets we call photons, when it is incident on this solar PV cell surface, it sets free the loosely bonded electrons of this n-type layer, and this forms negative. Similarly, the bottom layer, it becomes positive because it has got ability to accept electrons. So when you connect this positive and negative terminal to a load, it gives us a electric current. And commonly we can generate 0.5 to 0.6 volt with this PN type junction or this solar PV cells. And when an array of solar panels are combined, the desired amount of renewable energy we can generate. So this particular cell, combination cell, you can see this is a module, and we can combine these modules to form an array. Now, what is the BI characteristics of a solar cell? So you can see the if you do not connect any load across the solar cell, there will be the voltage will be quite high. We call it open circuit voltage. Similarly, if we short circuit the terminal across this solar cell, that is the positive and negative terminal, then it leads to a very high current. I have a few of the videos that is downloaded from YouTube. I will show you how hazardous it is. So now in this x-axis we have voltage, and in this y-axis we have current. So at zero current, that is the open circuit voltage is somewhat around say 21 volt for a system. Then when we increase the load current, gradually this voltage starts dropping. That's why it has got a characteristics like this. Now with the increase in current, this terminal voltage of a solar cell gradually decreases, and the manufacturer normally provides us with a BI characteristics of this solar PV cells, where there is an optimal operating point. This is the maximum power point. Beyond this point, if we increase the loading, then there will be a decrease in terminal voltage and there will be drop in output. So there is an important functionality here, that there is a device called charge controller. This helps to achieve this optimal point. Now, what are the types of solar cells, rooftop solars? That the various types, these are solar off-grid, solar on-grid, and solar hybrid. So what are these? First, let us see what is this off-grid solar system. So as the name indicates, there is no connectivity with grid. That's why we call it off-grid. So definitely this will be most suitable where there is a very limited reach of utility, or even in very dark forest area, means a dense forest area where there is no utility connectivity. So there, such type of off-grid solar rooftop systems, these are very, very helpful. So here the system is 100% self-sustaining. So during daytime, we generate and consume, as well as we feed the extra power to these battery banks. And during night hours, we utilize these battery banks, and through inverter, we convert to AC and consume this for our household use. So it's a standalone system with battery storage. Without battery storage, this kind of off-grid solar system will not work, because during daytime only this will give output, and in the evening hours, when there is reduction in solar radiation, the output will gradually reduce and system will stop working. So here the most important part is this battery package, and it requires a lot of maintenance because every day it gets charged and discharged. Just you can imagine we have inverters at home, and if we have very frequent power cuts in our utility, then what happens? It's basically lead acid batteries, and in nowadays we are using lithium ion cells. So, but this lead acid cells, these are still very much prevalent because these are easy to use, easy to maintain. So the water gets vaporized during this battery charging process and discharging process. So you need to top up water. So in this type of off-grid solar system, it's very, very important to maintain the battery water level. Otherwise, the system will not give you a very good life. So these are very maintenance prone, as well as regularly you need to clean. Now on grid. So as the name suggests, this is a system where we we have the option of installing battery bank. So if we install battery bank, it will be a hybrid. Otherwise, without battery bank, the solar panels, it produces energy, and through inverter, it is converted to AC. Now the inverter meets the household demand, as well as the excess power is sent to the utility. So here we have the option of pushing the energy to utility and get some credit for same. But it is also important here that these kind of solar cells, means solar rooftop solar system, you are bound to draw utility energy during night time or evening, after evening hours. Now it's a on-grid solar RTS, a very schematic. That is, this is the photovoltaic cell and grid tie inverter. Why it is called tie inverter will be coming through in we'll going through the future slides. And this is the meter. This is the AC disconnector, that is MCB, and distribution panel. So you can see this solar energy generated, it is pushed to the distribution panel, and part of that we consume, and the remaining we send back to the utility. Now during night hours, we draw power from the utility for our household requirement. Next, hybrid. So hybrid is a mix of that. So here there is inverter, and there is a battery bank associated with this. So during daytime, we have to install for this particular case, we have to install a solar panel that should be greater than our system demand. So suppose my household load is 1 kilowatt, and if we install 2 kilowatt solar PV system, then this 1 kilowatt hour, that 1 kilowatt energy instantaneous demand that of this household load, that will be catered by this solar system, and remaining will be used to utilized to charge the battery bank, and the excess power will be fed back to the grid. Now during night hours or after the evening, this battery bank will support till it is able, till it is drained, and thereafter we have the option to draw power from utility. So it's a better system, but again, since battery bank is involved, so maintenance here becomes a concern. So we need to maintain the battery banks here. Now, what are the components of a rooftop solar system? So rooftop solar system, the most important part is the solar PV modules or the solar panels. So depending upon the construction, we have monocrystalline, polycrystalline, and another two types are thin film and amorphous silicon panels. So what is monocrystalline? Normally, it is most of the panels that you see, it is monocrystalline, and it is first generation solar panels, and it is much more efficient because the this array is made of a single crystal. So that's why its cost of production also becomes high. However, its efficiency is much more. So this kind of solar system, it gives us an efficiency of 18 to 24%. And normally 36% of the solar panels sold are this kind of solar panel cells. Now polycrystalline, it consists of silicon fragments. That is, here in the above upper case, what we will see, it is a single crystal. It is made of the array is made of single crystal cells, whereas here crystal fragments. So these crystal fragments are dissolved in a substrate before producing the silicon slices, and this forms the PN junction. So definitely it is less expensive, but the energy efficiency, means solar panel efficiency, is almost comparable to above, that is around 14 to 16% and a bit cheaper. So that's why the market share is almost 20 to 23, 22.3, 24%. This is based upon a study as published by one Government of India website. Now, the third one is thin film. So thin film is commonly, it is not silicon, but it is a cadmium telluride. So the junction, instead of PN junction, it will be a junction of cadmium telluride and with some dopants. So it is slim, very, very slim, but it is less efficient, almost 18 to 21%. It is less costly and it is also very much prevalent. So where we need to, we have a low budget, we can go for thin film type of panels also. And amorphous silicon panels, these are the fourth type, which is thin and flexible. It is less expensive, but its efficiency is very, very less. So normally this type of solar panel, solar films, solar PV cells, you will find in toys, in we have solar system in cars. Nowadays, the roof of these cars, these are having this amorphous silicon panel. So here cost is less and these are flexible. So it is, user has got the flexibility to install it wherever the user wants. So these are few of the visuals of monocrystalline, polycrystalline and amorphous. Now, the other components, the most important is solar inverter. So as we know the term inverter. It converts the variable DC output of a solar PV panel to a AC power. Why it is variable DC output? Because the output varies with the availability of sun. Now, the most important feature of this inverter is it always synchronizes with grid. So what is synchronization? We will be going through this in further slides. That is the voltage and phase sequence, voltage, frequency and phase sequence of this inverter output. It has to be matched with that of the utility power. So why it is important, we will be covering in further slides. And the other component is module mounting support structure. So this module mounting structure, it has to be given, this has to be given a very high priority during installation, because it has to be hot galvanized and it has to be means corrosion free, the most important. Otherwise, what will happen? We normally install a solar system to get a life of useful economic life of 25 years. Now, by the end of 8th to 10th year, suppose the structure gets corroded and gets damaged, then whole installation goes into waste. So that's why this support mounting structure, design of this support mounting structure and its parent material of which it is made, it is very, very important. Normally, hot dip galvanized support structures are used to form this mounting support structure. And nowadays, extruded aluminium, it is much more popular because it is not susceptible to corrosion. And this support structure normally mounts a tracking mechanism that will be going through one YouTube video I have, so I'll be showing. And balance of system, it consists of fuses, cables, switchboard, junction box, and most important, it is the lightning protection system and earthing system. We will cover this in future slides. And one most important part is charge controller. So a charge controller, it has a charge regulator. It is also called a charge regulator or battery regulator, which limits the rate at which the electric current is added to or drawn from the electric batteries. So basically, it controls the battery charging rate, and in earlier slides, what we had covered, that the BI characteristic, if you remember. So the optimal usage point has to be achieved always for a solar PV cell. So this charge controller helps to regulate the charging rate so that the current is drawn in such a way that always the optimal power point, the Pmax point. Just I am taking to the earlier slides. Yeah. So this charge controller controls this charging current that is going to the load or the battery. So it controls in such a way that this maximum operating point is always met. So this is a design factor, and this is very, very important. Otherwise, if we, the choice of charge controller is very, very important. Otherwise, what happens if the charge controller fails to operate near Pmax, then either there will be a higher voltage across the terminals of the solar PV cells, or there will be voltage drop and less power. So the next, coming to next slide, one of the important aspect is bidirectional meter. So bidirectional meter are very popularly known as the 4-quadrant meter. That means it can record the import energy as well as export energy. So as evident from earlier slides, we are intending to use this solar energy generated, as well as we are also intending to use the, this utility energy during off-peak hours, and also we want to push our balance of electricity generated to the utility. So this meter, being a bidirectional meter, the amount of electrical energy that we are pushing to the utility, that is also recorded, as well as the amount of electricity that we consume during off-peak hours, that is also recorded. So in this way, this helps us to bifurcate how much solar energy that we are generating and pushing to grid, as well as the amount of solar energy we are, the amount of utility energy that we are consuming. And in some cases, we install gross meter, where it is the power generated from rooftop solar plant. It is not fed, not used by any customer, but it is directly fed to the grid. So there we don't need bidirectional meter. There we need gross meter, because bidirectional meter is always costly, because it has got 4 quadrants operation. That means import and export, both energy it will be recording. So definitely these kinds of meter involve high cost. So if we wish to generate the energy and push it to the grid, the purpose is sale of power to utility, then we don't need to invest much in bidirectional meter. We can have a gross meter. Now, this is the typical SLD of a solar RTS rooftop solar system, where this is the photovoltaic cell, solar PV cell. This is the charge controller, and this is the DC bus, where across this DC plus and minus, this is the battery bank. After that, there is an inverter. So this converts from DC to AC, and it feeds to the load, as well as it is connected to the AC bus. So from inverter, we can take certain priority load. So it will act like a UPS, as well as from the AC side output, we can feed our other non-priority AC loads, as well as we have a grid side connectivity. So this is the SLD, and this is a typical system. So you can very well visualize here. These are the solar panels, and normally nowadays these charge controllers are inbuilt in this inverter itself. So the inverter, it will be connected with the battery bank. Normally nowadays lithium-ion battery banks are very prevalent, and this inverter, it is connected to the household electrical load, as well as to the bidirectional meter, which is in turn connected to the utility. So the energy generated here, it will be going to electrical appliances, as well as it will charge the battery, and the excess amount of energy it will be passing to the, it will be going to the utility through the bidirectional meter. And in off-peak hours, suppose the battery is drained, then we can draw power from the utility through this meter. The metering will happen, and so this inverter, again, it will be fed to the AC load, and in fact, this can charge this lithium and battery pack also. So these are the typical installations nowadays available. Now, coming to the requirement of rooftop area. Normally the thumb rule is for 1 kilowatt we need approx 10 square meter of shadow free area. So shadow free means there throughout the day, I mean that is from we normally call it dusk to dawn. Sorry, dawn to dusk. There will be a good amount of solar fall. That is, there should not be any shadow. So the actual area requirement may vary depending upon the efficiency of solar PV module. This has to be also taken care because the type of solar PV cell that you are using, it has got a direct relation with their conversion efficiency. So as a thumb rule for installing 1 kilowatt solar rooftop system, normally we require 10 square meter of roof area. And in this orientation, that is, it is also important to install the solar panels in the direction that maximizes the sunlight exposure. So if we are in northern hemisphere, then it should be facing south, and if we are in southern hemisphere, it should be facing north. So it is quite obvious. And this nowadays robotic mechanism is also available, and a device, it is called pyranometer, which is used to measure the solar radiation, that is the solar flux density. It is measured in terms of watt per meter square, and depending upon the position of sun, it automatically changes the angular position of that solar PV mechanism. So I have a video on this. At the end of this presentation, I will be showing that video. So as we know, shadow will be there. That means there will be less production. So we will not get the full utilization from this capacity. So while installing, it will be very, very important to take care of this concept that the PV cells are to be installed at such a location that for future human activities, there should not be any kind of shadow or any kind of obstruction of solar light. Suppose if we install a system and we expect that it is going to give us a useful economic life of 25 years. Now, after 2 years, we see that one more building is constructed just besides our facility. Now, the investment that we have made, that will be going to be wasted. So normally the location that we have to choose, it has to be very, very judicious decision, because when we are aiming at a lifespan of 25 years, their feasibility study and this location decision, it is a important decision because it affects the payback. Now, the factors that affect solar generation, again, if we summarize the plant location, just now we discussed, that is, we need to place the solar cells after study in such a location that throughout its useful economic life, it should get the desired amount of solar radiation. Then quality of equipment used, that is the type of solar PV cell that we are using. And because different solar technology, PV cell technology has got different efficiency. Number of sunshine hours, it is related to particular region where we stay. Like if we are getting a good amount of solar radiation, for example, say in the state of Rajasthan. So we throughout the day will be getting a good amount of solar radiation, whereas say at some location where there is very high rainfall throughout the year, or there is very less sunshine, then definitely the solar PV cell that we are going to choose in that case, the system efficiency should be designed like that. Now the workmanship, definitely it also plays a vital role. Then PV module tilt angle and orientation. So this robotic tracking mechanism that I told, it is normally very costly affair, and the rooftop solar system, normally people don't install it because it will add to the cost like anything. However, I will show you a few examples where this uh, uh, tilting mechanism and auto tracking mechanism, it is taken care by a robot through sensing the watt per meter square through a pyranometer. But in rooftop solar system, this is not very prevalent because it adds to the cost like anything. So PV module tilt angle and orientation, since we are not getting auto tracking mechanism in household rooftop RTS, so definitely we have to fix the system in one particular angle. Now, for that particular tilt angle, if we are not getting maximum solar radiation during the day, then the overall system efficiency goes down. Then next is module cleaning. That is normally the issues that we face, the dust in the ambient that settles down, and the second important thing, bird droppings. So bird droppings, these are a very common phenomena in most of the area in India, because this it creates a very hard layer on the surface, which is, so regularly you need to wash up the surface, otherwise it will not go, and gradually it will damage the upper layer. And O&M activities, definitely it will impact, because if we not maintain those properly, or if we do not operate those those equipments properly, like this taking care of the battery bank or taking care of those connections, so obviously we are not going to get a good life of the system. And panel efficiency, while designing the system, it has to be taken care. Definitely this has got linkage with the budget available, but yes. Then system losses. System losses here, the most important part is the inverter. So normally inverters that are available in the market nowadays, it is 97 to 98% efficient. That means the conversion efficiency is 97%. So in the conversion process itself, you'll get 3% loss. And then lastly, this cleanliness, as we have discussed, that is dust or bird droppings. Now, what are the electrical protection? As you can see, if one solar cell is damaged, then the rest of the array can force current through it. So what will happen? It will create a short circuit like situation, and this will lead to abnormal flow of current and temperature rise in the cell. So even the whole solar PV panel can burn out. So to stop, to cater to this requirement, normally fuses are installed for each of these solar PV cell. And the phenomena, what we call hotspot. So if you take a thermography camera, then you will find that a particular region, it is getting more heated, a particular region of a solar PV cell. So it is creating localized hotspots. So that means this solar PV cell needs a replacement. And to prevent such kind of things, we normally use a blocking diode, that is a diode in series with the system. And also IEC 62548 standard, this defines that above 50 volt system, this has to be supported with a blocking diode, and also a bypass diode, or it is a clamping diode. So it will clamp the voltage across each of the solar panel. Then earthing and lightning protection. So this is normally the part, ironically, this is most neglected part of the design considerations. However, by installing a rooftop solar PV system, we are say inviting some kind of trouble, because definitely to avoid shadow and to get maximum generation, we are installing these panels at the highest point. Now it is definitely therefore creating a situation which is liable to attract lightning discharge, because it is at the highest point now. So installing proper lightning protection system, it plays a very important role here in this part of this slide. Just yes. So what the standard says, the air terminal of this lightning discharge system should be at least 0.5 meter above the top surface of the solar panel. And this has to be a dedicated earth pit. This has to be connected with a dedicated earth pit. So if at all a lightning discharge happens, the lightning energy will get discharged to this dedicated earth pit and will not damage the entire system. Also, we need to install surge protection devices at our AC/DV terminals. Also, this earthing of individual solar PV module, this plays a very vital role, because apart from though we install this air terminal, but if direct lighting strike happens to these solar PV cells, then this metallic body, this is connected to ground. This is insulated with respect to the PN junction again. So this outer part, we need to ground it so that any kind of direct lighting strike on these PV panels, that will dissipate the energy to ground and our household system will remain protected. Otherwise, one lightning strike and the whole household devices, especially the electronic devices like televisions, like microwaves, these are gone. So taking care of earthing and lightning protection, it is very, very important while installing a rooftop solar system. But normally people don't give much importance to it, but this has to be taken into consideration while designing a system. Now, one more feature it is there in the solar inverter, that is the anti-islanding protection. So what do we mean by island? Island means normally our generating system and load are paired and they are separated out from grid. So this kind of situation you can imagine when there is no utility power supply. So you can think of a situation when there is no utility power supply and my solar inverter continuously during daytime, and my solar inverter is continuously pushing power to the utility. So what will happen at the distribution transformer, it will get stepped up and it will feed to the 11 kV system, like means though the VA rating is very, very less, but it can create to a hazardous voltage. So it is very, very essential for safety of the workman at utility end, that anti-islanding feature. That means when the utility and power supply is cut off or it is not available, the solar inverter should immediately stop pushing power to the utility. So it is legally mandated by the distribution companies, that is a part of technical specification, that solar inverter should have anti-islanding facility. That means when the utility power supply is not available, it should not push any power to the utility. And the last one is synchro check protection. So as you had discussed earlier, that this inverter produces a voltage, AC voltage, and this has to be in phase, means the frequency and phase of this, and in fact voltage also it should match. It is single phase. In case of normally up to 3 kilowatt we follow single phase. So the voltage, frequency and phase sequence of this incoming, that is the inverter output, let we term this as source A, and the grid as source B. So voltage, frequency and phase sequence of this incoming source must match with that of the utility or the grid. Now, why it is important? Say at t equal to 0, the utility, it is at 0 amplitude, and the grid inverter, it is at 0 amplitude. So joining these two sources will not create any electrical fault. Suppose just source A, we consider this point as t equal to 0. So at t equal to 0, when we are connecting this inverter to the utility, so this waveform is at its peak. That means the incoming incoming source, it is at its peak, whereas the grid or the utility, it is at 0. So when we connect through a circuit breaker or MCB, we connect these two systems, then what happens? There will be a high amount of short circuit current. We call it synchronization fault. So it is an electrical fault and it may damage our entire system also. So it is very, very important that this inverter should be able to synchronize the output power supply with the utility. That is, the voltage, frequency, and phase of this AC power output of this inverter should be matching at any point of time with that of the utility. Now, operation and maintenance of solar PV cells, rooftop solar cells. So one most important part is module cleaning, which is very, very frequently required, and especially in places where dust or bar dropping nuisance are there. This is because this is directly related to decreasing the system efficiency or module efficiency. So this has to be periodically cleaned, and the module connections, these are to be, means the integrity of the module connection or tightness, this has to be checked very frequently. So there has to be a preventive maintenance schedule monthly or weekly as recommended by the OEM, and we need to perform these checks. Similarly, the junction boxes, any kind of heating, hotspot, and the tightness check has to be performed for the junction boxes. And structural mechanical integrity checking in between, it is also very, very important. Otherwise, with a cyclone or with such kind of things, the entire supporting structure, it may get uprooted. So it will cause extensive damage to the solar PV panels. Similarly, cable connection tightness. Yes, one more thing, when normally with this solar rooftop system, what we face that there are fuses for individual array. Now, if the fuse has blown for one particular array, then what happens? The output gradually reduces. So the system design is 5 kilowatt peak, but we usually get 2 kilowatt, 2.5 or 3 kilowatt. So this is a situation when due to some kind of fault in the load end or in the cable, there are blown fuses. So this has to be checked very often in a regular interval so that the region can be eliminated, and we can achieve the we can place back the fuse and we can utilize the system maximum. Now, if any lightning strike has happened, then it is very, very important to recheck the system and again use it. Now, the yield or the energy generation, how can we calculate? That is, for how much duration of a day we are getting peaks on hour, then what is the rated power? Suppose for on an average we get this peaks on hour. Suppose it starts with very minimal at 6 a.m. say, and gradually the amplitude is maximum, that is watt per meter square is maximum at between 12 to 1, and by 5:30 or 6 p.m. it is minimum. So if we take an average of that area, then suppose for 4 hours we get peaks on hour. So it is 4 hours into the rated power of array. Suppose we have installed two numbers of 320 watt maximum. So 0.62 kilowatt, that is the array rated power, or one panel say of 500 watt. So it is 0.5 kilowatt into system efficiency, because the overall system has got some losses, that is loss in cable, loss in inverters, loss in terminals. So if overall system design efficiency, it is say 20 to 30%, or say it is 0.3 say, and the duration factor. What is the duration factor? We will see in next slide. So combining all this, means multiplying all this, we get the system efficiency. And normally you will not get more than 20 to 30%, means 25%, it is at very high end. So system efficiency, you can see, we install a system that is 5 kilowatt peak, but that means if 5 kilowatt is generated throughout 24 hours, then 120 kilowatt hours should be the yield. But it is not like that. We will be getting 20% of 120 kilowatt hour, that is the net yield. So that's why the other popular term for this is plant load factor or the load factor. So we get only 20 to 25% depending upon the system design. So energy yield of a 25% is at very high end. Normally system don't give that. Maximum 22, 23 or 24%. It is at high end we will get maximum up to 22, 23%. So this is one table that is with temperature. Normally the design temperature, if we don't get, then there is almost 10% loss in efficiency. For dust we get 3% loss in efficiency. Manufacturer also gets a tolerance, that is 1 kilowatt system, so it will have 3% tolerance, so we will normally get 0.97, that is the efficiency factor. Similarly, the orientation, it is 0% we are showing because we assume that it is perfectly oriented during the commissioning. Tilt angle, it is 1%. Voltage drop, almost 2% efficiency loss. So overall, the system efficiency here it is calculating 0.72. And when we get the yield, the energy yield, it will not be more than 23-24%. Now, derating. As we have discussed earlier that we are installing a rooftop solar system, then we are expecting a useful economic life of 25 years. But at day 0, the guaranteed performance is almost 97.5% to 98%. But the question here is, at the end of 25th year, should we get the same design efficiency? No, this will not happen. This is for the solar PV cell. This will not happen because the solar PV rooftop module degrades over its life cycle at the rate of 0.7% to 1% per year. So every year there is 1% drop in the yield or the output of the solar PV cell. This is because the crystalline layer gets damaged with this solar radiation or the solar fall. And at the end of 25th year, if we are starting with a system guaranteed performance of 97.5%, then we will be getting somewhat around 80.7% at the end of 25th year. So that's why for such a system, taking 25 years of lifespan is better. And after 25 years, with such low efficiency, the system will not be a right system. We need to replace it. So that's why 25 years is fair enough time period that we should consider while calculating the payback. Thereafter, we need to replace the system. Now, rooftop solar potential in India. In India, we have a potential of 637 gigawatt of residential rooftop solar. It has been studied by Council on Energy, Environment and Water, that is CEEW. It was released in November 23. So as we can see here, the potential, first thing is potential, means what is the potential India is having, that is 637 gigawatt suitable rollers. All suitable rooftops are entirely covered with solar. So this is the potential. However, means feasibility. Then technical potential is 118 gigawatt, restricting the rooftop solar size to meet the household electricity demand. So technically, out of that 118 gigawatt, it is technically feasible. And economic, when we see economic potential, that means we'll get a good NPV or internal return rate, or IRR we can say. That is a term that usually we use while calculating the capex plans. So 102 gigawatt of estimation based on economic viability, means out of 118, 102 gigawatt is economically viable, means it gives some economic sense to install there. And the market potential is, because every customer will not be willing to install solar PV system on their rooftop, because it involves some kind of finance. So based on consumer willingness and consumer willingness to pay and payback in a 5-year period, normally the published figure was 11 gigawatt as per this CEEW. So India has a plan of renewable energy generation target of 500 gigawatt by 2030. So that's why honorable government has given a lot of stress on this solar and renewable power generation that we are going to cover in future slides. Yeah, this is a trend that in financial year 2020 we had 719 megawatt of solar power installation. Till 2019 we had 1796 megawatt of solar power installations, and this orange line, this is cumulative. So in FY21 this was 1924, and in FY24 till July 23 it was means April 23 to July 23 the figure was 1996 megawatt, and the target for FY24 end is somewhat around 4000 megawatt, that is 4 gigawatt, and the cumulative stands somewhere around at 12,000 gigawatt, 12,000 megawatt or 12 gigawatt. So Institute of Energy Economics and Financial Analysis and JMK Research and Analytics finds India's rooftop solar market is bubbling with new energy, overcoming major roadblocks to likely add a record of 4 gigawatts capacity in the fiscal year 2024. So India is eyeing at a potential rooftop solar potential of 4,000 megawatt or 4 gigawatt by the end of 24. So this is definitely a boon for us, because gradually the consumers will not be depending upon the utility generation. So there will be this energy can be diverted to some other sector so that the growth of country will happen. Now the state-wise share, we can see that Gujarat, it is having the highest share in terms of solar generation of this total solar generation capacity of India. That is, Gujarat stands at 26%. Next is Maharashtra 15%, Karnataka 14%, Rajasthan 9%, Kerala 5%, and Odisha we are in around 2 to 3%. But definitely this momentum has a good push in Odisha itself. So nowadays, more and more people are willing for this kind of rooftop solar system installation. Now, let us see what are the advantages and disadvantages of renewable and non-renewable. So renewable energy. So renewable energy, it is derived from natural sources, which can be solar, wind. So it is something which can be replenished. Whereas non-renewable energy, this cannot be replenished. So if we depend upon this non-renewable energy and we do not give due importance to renewable energy, then a day will happen when all these energy intensive systems, like means all the energy intensive industries one day will be seeing a great crisis, will be in great crisis. So this will affect our GDP. So that's why this renewable purchase obligation or RPO, this has been brought into picture. So what is this RPO? It is a requirement mandated by the central or and power, and that is the DISCOMs, distribution companies, and open access consumers. So what it says, just in next slide we will see. It says that every year the amount of energy that we are consuming for our the amount of energy that we are consuming for our sector, a particular percentage of that energy should be generated from renewable sources. So in 2024-25 financial year, the wind energy percentage should be, out of that, the wind energy percentage should be 0.67%, hydro 0.38%, distributed energy, it should be 1.5%, Other renewable, it is 27.35%, and total renewable, it should be 29.91%. So wind, hydro, distributed solar, and other form of renewable energy like tidal or the other can be RE energy through energy exchange. So 29.91% of self-consumption has to be from renewable sources. So this is again, you see, it is increasing year by year. So by the end of financial year 30, FY30, this 43.33% of self-consumption have to be from renewable sources. So how this will come? This in turn brings into a robust mechanism that is fulfilled through RPO obligation. That is, either a organization which is energy intensive has to, either they have to produce or they have to consume from the producers. So by this, if you can see, and there is a term called obligated entity. Yeah. So distribution licenses like the distribution companies like TPWODL and open access consumers. Open access consumer means they will utilize this grid infrastructure, and the generation facility is at one corner of India, and the user is situated at another corner of India. So this kind of mechanism, we call it open access systems. So the consumers, they will be utilizing the grid infrastructure and accessing the power through open access system. So they will be paying the national utility a certain amount so that they can maintain their system and infrastructure. We call it open access. So distribution licensee, open access consumers, and captive consumers. Captive consumers, you can see there are nowadays captive power plants. It is a very favorite concept. That is, there are power plants. Normally, it is coal-based or gas-based, and the industries, the required load of that particular industry is made by that CPP, and partly the excess energy is exported to grid. So these kind of consumers, we call it captive consumers. So distribution licensee, open access consumers, and captive consumers, these are the designated entities, means these are the designated customers, and they are bound to draw or purchase a part of their consumption. From this table you can see a part of their consumption is mandated here. That part should be from renewable quota. So remaining, they can use non-renewable sources, but they have to, from their self-consumption, 29.91%, say for this 24-25, it has to be from renewable energy source. Otherwise, they will be buying REC certificates equivalent. Suppose they are able to make it 27%. So remaining 2.91%, they have to buy RE certificates, and this will be from a just like this. For this, there is a Indian Energy Exchange and Power Exchange of India, that is IEX or PXIL, just like stock exchange. So this is a exchange mechanism, and here trading of power takes place. So what at the prevalent rate at which this REC, this has got a share price, or this has got a this REC certificate, this means RE unit, it has got a floor price and a maximum price. So within that, whatever is the price of that RE unit, they have to buy to comply to their legal obligations. So this is a kind of robust mechanism when the government is pushing. So that's why all these industries nowadays, they are going for solar power plants and rooftop solar installations for their business installations, as well as this distribution companies or discoms, they are pushing ahead with this rooftop solar system so that they can meet their legal obligations, the RPO obligations of their particular sector. So these are the institutions under Ministry of New and Renewable Energies, we call it MNRE, like the National Institute of Solar Energy, NICE, and NIWE, that is the National Institute of Wind Energy. Normally they do R&D activities and they give recommendation to the Honorable Government of India. And National Institute of Bioenergy, that is situated at Punjab. So these three are basically involved in renewable energy R&D sector. And similarly, other few of the PSUs is like that. And in state level, ORIDA, that is the Odisha Renewable Energy and Development Agency, and state designated agencies, that is the respective electrical inspectorates. So these are the state level nodal agencies which ensure that these guidelines that we discussed just now, it is enforced and it is met. So now coming to few of the commercially available and commercially viable RTS solutions, you can see this I have taken from Tata Power website. So if you have a rooftop area of 100 to 200 square feet, normally a 2 kVA and single phase system, it can give the best yield. And with this, you will be requiring two numbers of 12 volt 150 ampere hour battery and 320 watt peak 4 numbers of modules. With this, you will be able to generate 1400 units of electricity annually. Similarly, with a rooftop solar area, rooftop area of 200 to 300 square feet, 3.7 kVA single phase system can be installed. Similarly, up to 500, it is 6.25 kVA is most commercially viable system. It is available in Odisha. And up to 700 square feet, we can install a 7.5 kVA system, which is large enough because it generates 7,000 units. And with this, you can also utilize the excess power to get some incentive by pushing it to the grid. Now, considering the cost, there is a very popular term in this sector. We call it Central Financial Assistance, or CFA. So it is basically an incentive, or we can say cashback to the customer. So subsidy, we can say. So 40% benchmark cost, or 40% of the cost, it is for a 3 kilowatt peak system. It is the central financial assistance is 40% of this project cost, and it is for capacity beyond 3 kilowatt peak up to 10 kilowatt, it is 20%, and it is again this is not very clear. There is a table. Just a second. Okay, that I have missed to add. So up to 3 kilowatt, the CFA is 40%. 3 to 10 kilowatt, it is 20%, and beyond 10 kilowatt up to 500 kilowatt peak, it is 20% of the benchmark, or it is actually just less than 20%. Okay, so we can see a actual case study. This I have taken from TPWODL website. So just like in western part of Odisha, it is TPWODL. Similarly, northern part, southern part, and central part of Odisha. So for 1 kilowatt solar system, this is 50,000. This is rupees per kilowatt. So 1 kilowatt system, the cost is around 50,000. For a 2 kilowatt system, this is 47,250. So into 2, because this is rupees per kilowatt of installation. So as we increase the system capacity, we can see the cost becomes more and more effective. So on this cost over and above, we will be getting the CFA subsidy depending upon the type of system. So with this, we are at the almost end of our presentation, and I have certain links from YouTube, and let us see few of the successful solar installations in India. So I am just disabling the pointer and taking you through. Sorry. YouTube, where this is Badala Solar Park that is at Rajasthan. You can see how massive. This is not rooftop, but yes, definitely this is a point of interest with reference to the context, and I'm just sharing the same.
शुरुआत पाक के साइज से करते हैं। ये पाक
So the sound is audible?
Yes, it is audible.
Sound is audible, sir?
Yes.
Yeah, I'm playing the video again.
शुरुआत पाक के साइज से करते हैं। ये पाक इतना बड़ा है कि यहाँ मुंबई के वानखेड़े स्टेडियम जैसे 1000 से भी ज्यादा स्टेडियम बनाए जा सकते हैं। अब जरा इन सोलर पैनल्स को देखिए। सूरज की किरणों से पावर जनरेट करने की जिम्मेदारी इन्हीं की है।
India is blessed with sunshine and 330 days to 350 days in a year, bright sunshine, which is about 5 hours per day, bright sunshine. So that helps in solar power generation.
चलिए मैं आपको समझाता हूं कि ये पाक कैसे काम करता है। जब सूरज की किरणें मॉड्यूल्स के सेल से टकराती हैं, तो इलेक्ट्रॉन्स काम करना शुरू करते हैं। इससे डायरेक्ट करंट बनता है और सोलर पैनल्स की वायरिंग में कैद हो जाता है। फिर इन्वर्टर्स उसे ऑल्टरनेटिंग करंट में बदल देते हैं और क्लीन रिन्यूएबल एनर्जी बना देते हैं। सूरज ढलने को है और पैनल्स पर धूल जमने लगी है।
Dust is a major challenge for any solar power generation. Every day, because of the wind, so the sand gets deposited on the solar panel.
पैनल्स की सफाई के लिए इस्तेमाल किए जाते हैं स्टेट ऑफ द आर्ट पावर एफिशिएंट रोबोटिक क्लीनर्स। ये इकोपिया रोबोट्स व्हील्स पर लगे सॉफ्ट माइक्रोफाइबर्स से मॉड्यूल्स को बिना पानी के वैसे ही चमका देते हैं जैसे स्कूल जाने से पहले मैं अपने शूज को चमकाता था। कुल मिलाकर यहां से 2.25 गीगावाट पावर नेशनल ग्रिड को सप्लाई की जाती है, जिससे लाखों घरों को बिजली मिल सकती है। बादला सोलर पार्क न सिर्फ घरों को रोशन कर रहा है, बल्कि एनवायरमेंट फ्रेंडली होने के साथ साथ पावर की कॉस्ट को भी काफी कम कर रहा है। भाई वाह, एक सुनहरे कल की ओर कदम बढ़ाता भारत वाकई शानदार नजर आ रहा है।
So you will see, you can on demand, you can get the power from solar. You don't have.
Yeah. Next, I'm sharing the one more aspect, that is the safety precautions that we need to take care while we are maintaining a solar system. Normally, what we think that these rooftop solar systems are harmless, but it is not like that. So just let's have a look.
A common misconception is that solar panels stop working if the panels are damaged or broken. In this demonstration, we've connected a series of 20 250-watt solar panels to create a 5-kilowatt solar system. If you look closely at the panels, you'll notice that the glass in each panel is shattered to simulate the damage that might be caused by an event such as a hailstorm. Next, we connect a voltage meter and an amperage meter to the array to measure the electrical output. As you can see, even though every panel in the solar system is damaged, the system is still producing over 650 volts open circuit and nearly 9 amps short circuit current. This is a lethal amount of DC electricity, as you can see by the electrical arc we're drawing between the positive and negative wiring. This demonstrates that even when every panel in the system is damaged, solar systems continue to produce potentially lethal amounts of DC electricity. Even when seriously damaged by fire, solar panels continue to be a serious safety risk. Next, we connect the voltage meter and the amperage meter to the solar panel frame to determine if the damaged panels are leaking electricity onto the frame. The voltage reading is only minor at between 12 and 15 volts, which poses no serious threat of injury. To simulate rain associated with a hailstorm or water being applied to an incident involving fire, we then apply water to the damaged array to see if water conductivity affects the amount of electricity that leaks onto the solar panel frame. The impact of water is dramatic. The voltage on the frame immediately jumps from between 12 and 15 volts up to nearly 300 volts, creating a potentially life-threatening risk. If the frame arcs onto metal roofing, this can electrify the roof, guttering, and ladders leaning against the roof. This demonstrates that when responding to incidents involving damaged solar systems, such as clearing stormwater damage in wet conditions or attempting to extinguish fire with water, there is a threat of exposing emergency services personnel to unanticipated risks. In events such as short circuits, fires, floods, or storms, PV Stop is the only fast, effective, and safe way to shut down solar systems and mitigate the dangers associated with rooftop solar systems. PV Stop, making solar energy safe.
Now we are going to play one more video, that is the solar tracker that we are discussing, pyranometer and this automatic tracking facility. You can see here the tilt angle, it is automatically getting adjusted by this mechanism. And the feedback is from pyranometer. Here the tilt angle, it is adjusted through this automatic robotic mechanism. We will be playing one more video. Automatic cleaning.
This is an automatic solar panel cleaning system. Dust and dirt are effortlessly swept away, maximizing the panel's ability to soak up solar energy and boost efficiency. This is an automatic solar panel cleaning system. Dust and dirt are effortlessly swept away, maximizing the panel's ability to soak up solar energy and boost efficiency. This is an automatic solar panel cleaning system. Dust and dirt are effortlessly swept away, maximizing the panel's ability to soak up solar energy and boost efficiency. This is an automatic solar panel cleaning system. Dust and dirt are effortlessly swept away, maximizing.
The rooftop solar PV, RTS PV segment is one of the fastest growing segments across the world. In 2022, the world's rooftop solar capacity increased by 49% and is slated to continue the pace with installation of another 159 gigawatt by the end of 2023. Solar rooftop, with its flexibility, has some advantages. It offers the ability to provide reliable power for both rural and urban consumers, scale up investments through multiple investors, empower energy end users, and enhance energy security issues while helping utilities address critical transmission and distribution losses. In India, the Ministry of New and Renewable Energy, which is MNRE, had set aside a target of 100 gigawatt of solar capacity by 2022. It has a highly conducive market and investment environment and has seen significant growth in rooftop solar as well, most of it in just the last 3 years.
Here is some good news for you. From today,
If I'm
you
skipping
don't need
this,
to remember any Microsoft Excel
Yeah.
Hi, I'm Jayachand Shiv, and I lead the Renewable Energy Program at the Center for Science and Environment. According to MNRE's estimates, India has a solar potential of about 750 gigawatt. RTS potential can be estimated at around 30 to 40% of total solar potential on a conservative side. The solar sector in India has had significant growth over the past decade, especially with ground-mounted solar leading the way. Rooftop solar, on the other hand, has been lagging despite various policy measures and market mechanisms. This chart provides the growth in capacity of RTS PV in India over the past 5 years. Since 2019, which saw a 65% addition, the year-on-year growth rate has been consistent except for 2020, which saw a 39% dip from the previous year. The growth revived in the following years. As on 30th June 2023, total rooftop capacity stands at 12.7 gigawatt. By the end of financial year 2024, India is likely to achieve 4 gigawatt at a pace consistent.
Just here, I looked aside that in the earlier slides that we saw that India is aiming to have 4 gigawatt. That is very high. That is 4,000 megawatt solar capacity. So the target is very, very ambitious, and with the support of the decisions of Honorable Government of India, definitely we are going to achieve that.
Consistent with previous years. This next chart gives us the segment distribution. The CNI segment collectively accounts for about 80% of the total installed rooftop solar capacity. However, despite consistent growth, the solar sector has been able to achieve just less than one-third of the target of 40 gigawatt envisaged till 2022. On August 20, 2019, the Government of India sanctioned Phase 2 of the Grid-Connected Rooftop and Small Solar Power Plants program. The DISCOMs and their local offices were made the nodal points to implement this. The ministry later extended the deadline of the rooftop solar program Phase 2 till 2026. Under this program, 4,000 megawatt rooftop solar capacity addition is targeted through Central Financial Assistance, which is CFA, in the residential sector, including for households in rural areas. One of the important objectives of this second phase of the government program was to generate a supplementary rooftop solar PV capacity of 38 gigawatt by December 31, 2022. This was to be achieved by incentivizing the DISCOMs, of which 4 gigawatt for residential areas and 34 gigawatt for other sectors. According to the updated nationally determined.
Yeah, so these links I will be sharing with this presentation to sir, so that you all can go through it. One more thing. This is one last video of the session, that is one more solar installation at Rajasthan. Let's go through it.
दोस्तों मैं दावे के साथ कहता हूं कि आपने आज तक VLOOKUP फॉर्मूला यूज नहीं किया होगा। डेली प्रॉब्लम आ रही है एक से
After successfully commissioning and operating a 250 megawatt power plant in Pavgada for the last 2 years, we were ready for our next big challenge. The Pokhran and Jaisalmer belt receives some of the highest solar radiation in India and generates more energy than other regions. The unforgiving heat and severe climate makes this area unsuitable for agriculture, so it's best used to harvest solar energy.
Electric India is always ready to evaluate, adapt, execute, and demonstrate the projects with new technologies.
Some of the inspection of material, as most of the factories were not allowing visitors to enter their factories.
With a total capacity of 250 megawatts at one single site spread over 1,200 acres, 1 million solar panels and a peak strength of 610 laborers, the scale and timing of this project brought with it its own set of unique challenges.
So 6 million solar PV cells, we can think what a big facility.
ये प्रोजेक्ट काफी चैलेंज भरा भी रहा है क्योंकि इन्होंने कोविड के फर्स्ट वेव को भी देखा, कोविड के सेकेंड वेव अपने चरम पे था जब हमारा प्रोजेक्ट बिग टाइम में।
Procurement and erection team and some other vendors and contractors was the part of this execution, which well done given their performance and their all efforts.
Managing a project this big in scale during the worst global pandemic of our lifetimes meant adapting our age-old processes to align with government mandates and our own high safety standards. To begin with, we conducted the design and engineering work remotely from home. For timely equipment delivery at site, we had to take into account closure of vendor factories during the lockdown. The labor camp was successfully managed, keeping all
My name is Ram Kirpal Gupta. I am working with Electric Photovoltaic India Private Limited.
Skipping this part. So you can see what a vast facility. So I wanted to share all these videos because though our session is on rooftop solar, but yes, this is quite related, and we can have a feel that how India is driving these ambitious solar projects, and especially the 4,000 megawatt, that is the 4 gigawatt rooftop solar installation target till the end of 2024. It's very ambitious. So definitely we will be achieving it because there are a lot of government subsidies and other central financial assistance is there, and gradually this concept is gaining momentum. More and more people are going to are willing to take benefit of this, because the energy that we generate from a solar system, that is after the payback period, normally it is 5 years, it is almost free. But that you need to maintain the system, so that the cost that you will incur, it is only on maintaining the system. So the future in this sector, it is very, very promising and also very, very challenging because of the world macroeconomic scenario. So with this, we come to the end of this session, and thank you. I would